All right, in the last video we talked about some difficult and probably controversial things about how we can see fractal processes and we can then create logical nesting, kind of like a Russian doll. Now I see that all of science is a process of individual humans interacting and communicating and thinking and investigating. Well, every one of those humans requires a consciousness. Okay, cogito ergo sum. So the base logic of science is founded in the consciousness of man. So the consciousness of man is the superset, and then science is a subset of that. Well, I think that when we look at life, we see the exact same thing because all of life is a complex symmetrical network. So we can look at you know populations of humans which create a society, and then there's populations of thoughts within those societies. So math is a population of thoughts, politics, science, economy, you name it. That is like a network as well. That's like a living organism. And so the base logic of any living system, of any population or colony or complex network, that's the genetic code. So in my view, the genetic code is to life as consciousness is to science. So the genetic code, I see it as a consciousness. It's that foundational logic that's required before we can start seeing these amoeba and starfish and you name it. So that's the basic idea. This is a fractal algorithm. This is a fractal ideology. This is a fractal paradigm because the genetic code is a fractal code. Okay, it's a code that builds itself. So when we start talking about fractals, we got to start talking about measuring. We got to have a way to measure a fractal. England, a dodecahedron, and a codon are three versions of the same thing. They're things that need to be measured, and they need to be measured fractally. So if you were going to measure the coastline of England, the length that you would come up with would be dependent on the size of the ruler that you use. This is Mandelbrot's analogy. Okay, so as your ruler gets smaller, then the curve gets more curved, and so the coastline gets longer. So the measurement depends first and foremost on your ruler. And now we have to have a ruler. We have to animate the ruler. It can't just be a static ruler because now it's becoming animated. So we've already seen how that works with a dodecahedron, and we then need to figure out how that works with a codon. We have to measure the entropy of a codon, okay? Because the codon is a unit of entropy, okay? It's a complex entropy network, okay? So when we do it with a dodecahedron, we already know that we can break all of the symmetry of the dodecahedron down to one line. We can imagine a line that has infinite access. Well, then it stops at certain points, so we can break the symmetry one point at a time. Well, when we do that, we create a code of 1 point on the dodecahedron. Okay, then we can break it down 2 points at a time. When we do that, what we do is we take that line and we just mirror it. Now, all of a sudden, we create a different code. These are all sets. Okay, there's a set of 1 point code. There's a set of 2 point code. Now, when we do it 3 points at a time, it gets, now we're going to do it like this, but it's easier. We know that these three objects are derived from this one object. So now if we do it 3 points at a time, we could do it like this, we could do it like this, or we could do it like this. So now we can see that these sets of 3 points within the dodecahedron, they can be animated as a unit of broken symmetry. Well, that's what a codon is. It's an animated unit of broken symmetry. We start with perfect symmetry, we break it down. 1 point, 2 point, 3 points. Okay. When we break it down to 4 points, now we have a unit of measure for the dodecahedron that's this. So now we can see that breaking the set of 20 points down to a set of 4 points creates a logical code that can span the entire dodecahedron, and it's programmable. Okay, we can use units of broken symmetry to move the tetrahedron. Well, we can keep going from 4 points to 8 points and get this. So now what we can see is this fractal breaking from 20 to 8 to 4 to 2 to 1 to from 20 to 8 to 4 to 3 to 2 to 1. Okay, so there's a progression of symmetry breaking within the dodecahedron, and these are used, we can now use these as rulers or measurement devices for measuring the broken symmetry. Okay, that's exactly what life did. Okay, I forgot to print it out, but maybe I should do that. Maybe I'll do that in the next video. I'll show you what, yeah, I'll do that in the next video. Anyway, we now know that this process of symmetry breaking becomes a logical code that operates this mechanical device. It's a machine language, a symmetry breaking machine language. Okay, and when we do it with the object that is the genetic code, we create this code, a machine language, which is logically isomorphic with the data in the table that they generated, the codon table. That data creates the logical isomorph of this machine language. Well, there's only two possibilities. Either the table caused the machine or the machine caused the table. Well, I'm not going to believe that. I don't believe that this table caused this machine. I believe that this machine caused the molecules in that table. And it's not an accident that they operate this machine, because it's the machine that caused the damn molecules. So, I mean, I don't see how that's even hard to understand. That's just simple logic. Okay, so this thing's got this code, and now it's learned this language to operate it, and so then it's just going to friggin' operate it. But we can use these units of broken symmetry to actually measure the entropy in the units of the code. So each codon has an inherent entropy in and of itself. But as life steps through the process like this, this is a process of breaking symmetry. Well, as it does this, it creates new levels of entropy in the codons. Okay, well, it's not just doing it for shits and giggles. It's doing it because that's what it's going to use to operate this code. This is a functional imperative. There is a functional and it's imperative. This is the functional imperative. It's imperative that life can operate this machine, that it can do this math. Okay, it's doing it so it can build this curve. And it has to learn how to build the curve as it's building it. It's building the curve, and in the process it has to search. It has to explore. That's what learning is. You send out feelers and then they come back and they say, that worked, that didn't work. So then it learns. It's being trained. It's training itself. It's just like an artificial intelligence. It's a machine learning algorithm. So what it's doing is it's using this symmetry as a search algorithm. Okay, and it's clear. It's crystal clear. It is crystal clear that that's what it's doing. This is a graphical representation of a mathematical search algorithm. Okay, this is what it's doing. It's searching. Okay, it's searching for the things that help it build the structure in the most complex, the most entropy preserving way. It's building the entropy of life with each piece of the machine that it builds. So we can take this idea of an animated ruler that measures the coast of England, and we can create this idea of an animated ruler that measures the broken symmetry of space. We can apply that to codons to measure the entropy of the codons, because that's what they're all about. This is the animated ruler of life. This is the basic unit of space and time that it's using to build the mathematics of life. Okay? If you don't know this, then you're just pissing in the wind. You don't have a clue. Okay? You got to know this first before you could figure out all this other stuff. Well, now we know this. We know this is true. We've mathematically proven it. We've applied it. We're using it in a practical way for our thoughts and knowledge and our language, what we can say out loud without shame. You should be ashamed to say this. You should be ashamed. This is childish, okay? This is childlike. We don't have to be ashamed to be childlike because we're right, okay? We break the symmetry. We use that as our entropy. We build a complex network of logical relationships. And this fractalization is how life works. I mean, we talked about how we build this. We can build this curve with this network of logic. Well, we need to multiply this times 1 billion because that's what life's doing. I mean, this curve here, this is a single line. I mean, if you should be able to put your pen on this paper. It's just a black and white line. You know, the curve gets more curved as the ruler becomes smaller. And this damn thing is infinite. This is generated by a very simple power series equation. Okay, but it's generating an infinitely curved line. Okay, we need to think about life in exactly that same way, except instead of a single line, it is a complex spatial field. It starts with your typical crystal stuff. Think of a crystal as this single line. Well, now it's complexifying it as it builds it. It's learning to build it. So it's a process that starts at time 0 where it's a perfectly symmetrical thing. But then it's starting to use broken symmetry to make the crystal more complex. What life wants is to build the most complex crystal in the universe. It's seeking the parts. It's learning the parts that it can use to build this crystal. So now we have this powerful visual tool, but we also have these mathematical tools that we can use to start measuring these things, and then start saying, why did it pick this instead of this? Why did it pick this instead of this? Because life is making choices, selecting units of broken symmetry. That's what these are. These are highly evolved, highly selected, highly optimized units of broken symmetry. They come together in a network of logic, spatial logic that changes through time. That's what life is. Okay, so as we go forward with this new paradigm that works, that doesn't suck, we can start building ideas with it that are pertinent, that are relevant, that are highly useful for understanding biology. This changes the way we should see biology. Okay, a lot of the stuff they're saying now is just stupid. Like this, that's stupid. Okay, quit saying that. So if we change to this new paradigm, now all of a sudden, we can actually see what the function is, and we can see how life is accomplishing that function. So this is an incredibly elegant and powerful and beautiful paradigm, but you're going to have to take your friggin' mask off. You're going to have to open your eyes before you can see it. So that's what we'll do going forward. I'll get that other stuff printed out. We'll do another video.